Bismillahirrahmanirrahim. The topic of my presentation is textile seed. Seat belts are used for the protection. According to the World Health Organization, road accidents are a worldwide problem and now results in over 1.2 million people die every year from road crashes around the globe. Seat belts and airbags are highly effective in preventing death and injury from traffic collisions. Seat belts are expected to reduce the overall risk for serious injuries in crashes by 60 to 70%. Seat belts, also called safety belt, is designed to secure the occupant of a vehicle against harmful movement that may result from a collision or a sudden stop. It is designed to deliver non-recoverable extension. Seat belts are intended to reduce injuries by stopping the wearer from hitting hard interior elements of the vehicle or other passengers. Next, we come on to the seat belt market scenario. First, we will discuss about the global market for seat belts. According to the market research firm, the market for all type of narrow fabric is estimated at US $2.4 billion in 2005. This is projected to grow at about 3.6 per annum during 2005 to 2010. Next is domestic market for seat belt. The growth in the seat belt usage is expected to be more than the overall growth in passenger cars due to the stronger growth of the high-end cars with more seat belts. The domestic production of seat belt webbing is around 4.3 million meters. Next, we will discuss about the type of seat belts. There is lap seat belt, sash seat belt, lap and shoulder belts, 3-point belts, 5-point belts, and inertia reels. First, lap seat belt. Lap seat belts are simple adjustable straps that stretch over the waist. Next, sash belts, adjustable strap that goes over the shoulder, used mainly in the 1960s but of limited benefit because it is very easy to slip out of in a collision. Next is lap and shoulder belt. This type of belt combines the lap belt with a sash to provide shoulder and upper body restraints as well. It helps to keep the upper body from moving forward in a collision and reduces the risk of spine and brain injury. 3-point belts. These belts are similar to lap and shoulder belts but are made up of one continuous length of belt materials that avoid the stud-based mounting system. Instead, it weaves the fabric through the frame itself and then across the body into the locking mechanism. This design allows the belt to equally spread collision energy over the shoulders, chest, and pelvis. 5-point belts, most often found in race cars and child safety seats. This style is more restrictive than other safety belts and considerably safer. Essentially, two combined shoulder belts, each mounted to the frame for added safety and stability. They are connected to a belt and strap between the legs to accomplish the 5 points to fully restrain the body to the seat and vehicle. Last but not the least, inertia reels. Not technically a safety belt, inertia reels are integral in making seat belts more comfortable without losing their inherent safety. These allow belt to be adjusted for fit and comfort by letting out as much belting as is needed under normal conditions. Now we will discuss the importance of seat belt. The job of the seat belt is to hold the passenger in place so the passenger is almost part of the car, which prevents the passenger from flying forward as the car stops abruptly in the case of a collision. Now we will discuss about the fiber used for seat belts. Raw material used for seat belt webbing are nylon, PET, and its derivative like HDPY. Nylon was utilized in some early seat belts, but due to its high UV degradation resistance, polyester is now widely used worldwide. Also, polyester scores over nylon because of lower extensibility and higher stiffness. Next is the fabric structure. Seatbelt structures can be single layer or double layer and manufactured on needle looms with plain weave, 12 weave, satin weave. Normally 2x2 12 structure is used. The needle loom used presently is shuttleless and capable of delivering over 1000 picks per minute. The seat belts are made from nylon filament yarn or polyester filament yarn, which is woven to produce the webbing pattern. Next is the manufacturing method. This figure shows the pick needle insertion in shed, and the next one is selvage formation with catch cord yarns. In the needle loom, the weft is inserted from one side of the warp sheet, and here a selvage is formed. The other side of wrapping is held by an auxiliary needle, which manipulates a binder and a lock thread. Once these are combined with the weft yarn, a run-proof selvage is created. Special care is taken when constructing the selvage to ensure it is abrasion resistant. It is equally important to ensure that the selvage is soft and comfortable to wear. In a needle loom is used to move monofilament and multifilament weft yarn across width of the web in a single shed. A high tension applied to the monofilament compared to multifilament yarn so that it does not protrude beyond selvage. Monofilament weft yarns are rigid yarn that provides good stiffness across web and high resiliency. Monofilament weft yarns are used under high tension, which controls webbing softness and round shape together with each cord with catch cord yarns and finer warp yarns in selvage than body of the webbing. Low longitudinal stiffness and thinner web gives good winding performance with use of smooth monofilament weft yarns. Selvage warps are having about 66% lower thermal shrinkage than body warp threads. Weft threads are having 16% higher dry heat shrinkage than selvage yarns. Thus, woven ribbon is heated upon after dyeing. This gives soft, round shaped selvage. Then we will discuss about the finishing of the seat belt. The woven seat belt webbing is then transferred under tension to a dyeing and finishing range. The grey webbing is dyed and heat set, while webbing made from spun dyed yarn is heat set only. Heat setting is undertaken to impart precise extension to the webbing and suppress its recovery in the event of crash. This is achieved by shrinking the webbing in a controlled manner, which increases the weight of webbing from 50 gram to approximately 60 gram. Seatbelt webbing can be colored by two methods, either by incorporating spun dyed yarns or by piece dyeing. The appropriate technique for piece dyeing polyester webbing is by thermosol process. Next are the quality requirements of seat belt. The seat belt is required to have the following properties: static load bearing capability up to 15 kg, 1500 kg and extensibility up to 25 to 30%. Then abrasion resistance, heat and light resistance, lightweight, flexibility for use. Next are the performance tests and standards for the seat belt webbing. These are width, thickness, breaking strength and elongation for dry and wet webbing, abrasion resistance at various environmental conditions and in contact with buckles and fitting, influence of extreme environmental conditions and temperatures, rubbing fastness, microbial resistance. Next are the various defects which are most commonly in the seat belt. These are fraying and UV damage. Fraying is one of the most noticeable defects in seat belt. Fraying is where fiber break in the weaving. This results in reduced strength. Seat belt should be repaired or replaced at any sign of fraying. Next is the UV damage. Over time, UV rays will damage seat belt. UV damage is more frequent in helicopters and aircraft. Due to ever-increasing concern on safety of passenger during accidents, seat belts show better holding position in technical textiles market. Thank you.